Hey, hope all is well. Today we're going to be covering briefly global pressure belts and global wind systems right after that. I want to cover these in person or in video because they're super important systems that are global, that have an effect on global climates and then global temperatures, global moisture processes, weather, plants, animals, where people live, and a whole bunch of like normal daily life things as well as physical geographic processes. So cover them in video. So you're going to want to start with global pressure belts. This is Earth. Here's the world. It's a big round circle. Right in the middle is this line. That's the equator. And the first global pressure belt is this low pressure system that goes right across the middle that is called the equatorial low. The equatorial low is a low pressure system, obviously, that hovers typically right around the equator. It actually follows the subsolar point, so wherever the equatorial low is, it actually changes based on the seasons. You know that the subsolar point moves north and south depending on the seasons. When it's summer for us, subsolar point is slightly north in the tropics, so the equatorial low actually shifts slightly to the north with the subsolar point. And then when it's winter for us, subsolar point moves south in the tropics again, but in the southern hemisphere, so the equatorial low again shifts to be towards the south. But what you know about low pressure is that it pulls moisture in towards it. Low pressure systems usually have clouds, and so wherever this is throughout the tropics, there's this almost permanent band of clouds in the tropics wherever the subsolar point is, so that you can actually tell what season it is on Earth. If you look at like a satellite picture from space, wherever that equatorial low is, wherever the clouds are, if it's in the north, you can tell it's summer. If it's in the south, you can tell it's winter or December. And then if it's in the middle, it's either November or September or springtime, April, based on where that belt of clouds is. So that's kind of cool. But it pulls moisture in towards it. And then what you happen to find is that the location of pretty much every rainforest on Earth, all your major rainforests, are also located where the equatorial low normally is. And so this pulls in so much moisture that is the cause of rainforests being rainy. So here's a globe. And if you look at the location of all Earth's major rainforests, South America, right here on the equator, equatorial low, keep going around. The Congo in Central Africa, major rainforest, right under the equatorial low. Keep going around to a bunch of warm ocean water in the Indian Ocean. And then throughout Southeast Asia, Borneo, Indonesia, New Guinea, these are all major rainforest areas. And those are all located under the equatorial low. So super important system. Moving outwards from there, the next set of pressure belts is a pair of high pressure systems. Oops, red doesn't work. This is supposed to be blue anyway. High pressure systems on either side of the equatorial low. And those high pressure systems are called the subtropical highs. Subtropical high and subtropical high. Cool. So what you know about high pressure systems, high pressure is dry, moisture is pushed away from high pressure towards the low pressure. So what you have under the two subtropical highs is the location of all of your major, biggest deserts on Earth. So let's get our globe again. Subtropical highs usually are going to be found around 25-ish degrees north or south. And so on Earth here, 25-ish degrees north, you've got the American Southwest deserts. Keep going around. In the southeast of the United States, it's more humid because of this warm ocean Gulf water. Come across to Africa, you have the Sahara, the largest desert on Earth. come across the Arabian Desert, Arabian Peninsula, also huge deserts. The Gobi is a different desert region. It's not determined by the subtropical high. We'll cover that later. And then in the southern hemisphere, you have the Namib Desert of southern Africa, Australia, which is a whole bunch of desert land. And then in South America, you have the Atacama Desert in Chile, one of the driest places on Earth, which is just outside of the Amazon, one of the wettest places on Earth. But the Atacama Desert in Chile gets about 1 inch of rain every 10 years. Super dry, and that's located underneath the subtropical high. All right. Moving outwards from there towards the poles, you have another set of low pressure belts. These are located around 50 degrees north, 50 degrees south. They're called the subpolar lows. Subpolar low, subpolar low. Cool. Subpolar low, northern hemisphere, subpolar low, southern hemisphere. Same thing. Now, just like the equatorial low, subpolar low pulls moisture in towards these locations. So these are really all the wettest parts of the world that are not in the tropics. So if you're in an area that gets lots of rain and it's not in the tropics, well, it's probably in the subpolar lows. So around 50 degrees north or south, going around the world, you've got the Pacific Northwest, which is like Seattle, British Columbia, very rainy places. Go across North America, Canada gets a fair amount of moisture. Europe, England, it's cloudy very often. It's the same climate as like the British Pacific Northwest. England's super cloudy all the time. If you go there, people freak out when it's not a cloudy day, but they get rain very often. Go across Northern Europe, same thing, rainy, cloudy often. Across Asia, similar. And then in the southern hemisphere, there's actually no land at 50 degrees south at the right latitude under Africa. In South America, or near Australia, there's New Zealand. New Zealand is right around 50 degrees south. New Zealand gets a whole bunch of rain. Again, similar climate to the Pacific Northwest. And then come around to South America, just a small bit of land is at 50 degrees south, and that's Patagonia. Patagonia is a jacket company. What kind of jackets they make? Rain jackets. That should tell you something about how rainy it is in Patagonia, that there's a jacket company named after that. So subpolar lows, lots and lots of rain. Moving further outward, north and south from there, you've got a big high-pressure dome and a big high-pressure dome right over the Arctic and right over Antarctica. These are called the polar high and the polar high. Cool. Polar high, polar high. Same name, one in the northern hemisphere, one in the southern hemisphere. So the polar highs, these are strong, dominant, high-pressure systems. Don't be fooled by me just drawing one H. They're just as strong as the other high-pressure belts. But in the Arctic, in the northern hemisphere, where our inflator valve is, there's ocean. So the high pressure is not as dry as it is in other parts of the world over the Arctic. But that high pressure belt does send Arctic storms out of the North Pole down into North America for the rest of the US. And it does send storms out of the Arctic, again, down into Asia and Europe for all those people. So a lot of like harsh weather storms, daily storms and changes that a lot of the United States, Europe, and Asia experience are all storms sent out by the polar high to lower latitudes. Now in the southern hemisphere, the polar low is centered above Antarctica. So you have this big continental landmass in Antarctica, and that landmass combined with the southern polar high makes it so that Antarctica is actually one of the driest places on Earth. Most of the whole thing is this polar desert where they get very little precipitation, and any precipitation that they do get is in the form of snow. So super cold, but also super dry. They usually get like 1 inch of rain per year. So it's like if you go to bar trivia, it's a good trick question is what's the driest desert on Earth? Everybody wants to say the Sahara, the Atacama. So usually the answer is Antarctica is the driest desert on Earth. Sort of trick question, but it does count as a desert. Okay, so that's global pressure belts. Let me erase this real quick. Cool. All right, next, global wind systems. Global wind systems are all going to be based on the global pressure belt. So you might want to pause the video, rewind it, draw all those, get them down on a piece of paper, and then look at it as you're looking at these. Drawing things is going to help you learn it, it's going to help you remember it anyway, so it's not a bad idea. So global wind systems, draw the Earth again, big and round. Draw the equator right in the middle. There's going to be 6 of these, so you want to take up 6 lines of paper if you're using paper to draw it. We've got the equator in the middle again. Okay, so the global wind systems. These are going to go from high pressure to low pressure in every situation. So I'm going to draw in the high pressure belts just as reference lines. So here's high pressure. On the equator, you've got low. Oh, low pressure is purple. And then at the mid-latitudes, 50 degrees north, low, 50 degrees south, low. All right, so wind systems are gonna go from high to low, like we said a whole bunch. Okay, so the first set of systems. These go from the subtropical high towards the equatorial low. Wind systems follow the Coriolis force, which is deflection caused by Earth rotation. So if Earth is spinning that way, here's Earth's rotation, spinning that direction, then winds are going to move based on that Coriolis effect. So in the northern hemisphere, deflection is to the right, and in the southern hemisphere, deflection is to the left. And so we'll experience that with our first wind system. So again, these are going to go from the subtropical high down to the equatorial low. So they're going from high pressure to low pressure, and they're being deflected to the right in the northern hemisphere. In the southern hemisphere, same thing, they're deflected to the left, and they go from high to low pressure. So you have this wind system that travels that direction around the world, from high to low pressure, and this is called the trade winds. The trade winds. You've probably heard of the trade winds before. People who live in tropical environments usually think of the trade winds very favorably. It's normally hot in the tropics, you knew that already. But trade winds come around during the afternoon, typically when it's hot. And they're a nice breeze that cools everything off. Now they do change seasonally. When subsolar point shifts north in the summer, the whole trade wind system shifts north with it. And then in the winter, when the subsolar point shifts south, the whole trade wind system shifts south with it again. But if you follow surfing at all, you know that Hawaiian islands have good surfable waves on different sides of the islands based on the season. And so the north shore of Oahu only hits at certain times of the year, and southern facing beaches are going to hit at other times of the year based on what side of the island is getting hit by the trade winds, which is, again, seasonally dependent. But normally these are nice, cool, calming winds that blow away any insects. They often bring rainstorms because they are blowing across warm ocean water. It's tropical water. And so if it hits an island, then it brings a big storm with it. But if you look at a map of precipitation on any Hawaiian island. Usually the north side of it is super rainy, cloudy all the time. Hilo, Hawaii has a university onto it and a big meth problem. But if you go to Hilo, it's cloudy like every day. And that's because of these northeasterly trade winds. Other side of the big island of Hawaii, it's cloudy again because of the trade winds in a lot of spots, but it's actually got a desert climate in some places because the mountains protect it from the trade winds, so they don't get exposed to trade winds as often. So they're not as windy and not as moist because they're blocked by from the trade winds. So trade winds, they deliver moisture from the subtropics to the tropics. They deliver rain to the rainforests, and they actually pull moisture away from the desert. It's kind of like a big conveyor belt going from the subtropical high towards the equatorial low, going from the deserts to the rainforests around the world. Not that the deserts have the water, it's more pulling from like ocean to ocean usually, is what a lot of the world is. But again, throughout this area, tropics are mostly water around the world. In southern Asia, you've got India is like subtropical. This is the equator, okay. Coming through Southeast Asia, Northern Australia. Northern Australia actually does have rainforests. Continuing around Pacific Ocean, like I said, mostly water. And then you've got Central America and Northern South America that are mostly influenced by the trade winds. And then coming all the way around, we skipped Hawaii out here. All right, next global wind system. These winds, again, blow from the subtropical high, but this time they're going to blow towards the poles to the other low pressure system, the subpolar lows. So again, they follow the Coriolis force. In the northern hemisphere, that deflection is to the right, so they're going to do this. In the southern hemisphere, again, going from high pressure to low pressure, the deflection is to the left. So there you have it, those winds. And these are called the Westerlies. Hopefully, as you read online, winds are named by their origin. So these come from the west, they blow towards the east, so they're called the Westerlies. Again, come from the west, blow to the east, Westerlies. Trade winds, these are, you could give them their full name, northeasterly trade winds, because they blow from the northeast to the southwest, and then southeasterly trade winds, they blow from the southeast to the northwest. Westerly winds probably influence the most people on Earth out of any other wind system. If you think about any major city on Earth, with some exceptions like Singapore, most major cities are found in the mid-latitudes. Same place that these westerlies blow across, between like 25 degrees north, 25 degrees south, to 50-ish degrees north and 50-ish degrees south. That's all of the United States is between that latitude range. Japan, a whole bunch of China is within that range. Korea is within that range. Pretty much all of Europe is within that range, except for Northern Europe. And then Southern Hemisphere, you've got, it doesn't fit the rule as well because the land masses are different. But you've got a lot of, well, Southern South America, no land down here. Most of Australia, the populated Australian cities are all in the like southern part of Australia. And then South Africa has some populated cities as well. So that's where all the people are, in the mid-latitudes. And so the westerly winds bring west to east blowing wind to all those mid-latitude people. When we talked about global temperature differences, one of the major things that causes temperature differences that wind and air circulation, and really all I talked about was like the west to east blowing wind. This is what makes it so that west coasts are more mild than east coasts. So that west coasts have a strong maritime influence and east coasts have mostly continental influence because the westerlies blow from west to east across all those land masses. Yeah. Okay, final wind system is going to come from the poles. So it goes from the polar high down to the subpolar low, deflection to the right in the northern hemisphere. In the south, it's going from the polar high to the subpolar low, deflection to the left in the southern hemisphere. And these are simply called the polar easterlies. And the polar easterlies. These are strong wind systems that are noticeable more in the northern hemisphere because there's people there than in the southern hemisphere, because in the southern hemisphere where these are, between the pole and your like 50 degrees latitude, there's nobody, Patagonia a tiny bit, but nobody, New Zealand a little bit. But then in the northern hemisphere, this is where you have a lot of major land masses. Is from the North Pole, you have Asia, Northeast Asia, North America, Alaska. There's not that many people. Canada, okay. A lot of northern United States, and then northern Europe again. But the polar easterlies in the north will bring a bunch of storms, like I mentioned a minute ago, from the Arctic down across the landscape. So like if it's a cold, stormy day, a cold storm system that brings snow, maybe hail sometimes for Southern California, but really snow systems across the United States, those are pretty much all brought by the polar easterlies down across the country. And so if you look at weather maps or watch the news, all the storm systems that, like, okay, any big storm that's hitting the US, they're going to travel pretty much all from the north down to the south in the United States because they're sent by the polar easterlies. So that's kind of a normal thing. Okay, hopefully that helped. Fun to be here. Have a good one. Don't forget to hit that like and subscribe. See you next time.